Okay. Now we see the envelope detector. Now you tell me what is the advantage of envelope detector? The advantage of envelope detector is cost is less, complexity is less, hardware implementation is easy. So these are the main advantages of the envelope detector. Now by gaining these advantages, then we have to choose that the condition mu is less than or equal to 1, suitable time constant. Now all these conditions which we are concentrating, okay. But some of the students are asking that, no sir, I am not interested on these conditions. I am not interested on this particular addition, subtractions, all these things. Then if you want DC signal, without DC signal, I want to get the original message signal. Now that demodulation is nothing but synchronous detector. But that is easy or not, and you are gaining this kind of advantages or not also, you will see. Now synchronization, the name itself, synchronous detector. Now see here. Now, but in the synchronous detection means what? In synchronous detector, first you want to identify. Synchronous detector means no DC, means definitely over modulation, means mu should be greater than 1. So no DC component, over modulation. If there is no DC, now what is the modulated signal? The modulated signal is nothing but just a message signal multiplied with carrier. So this is AM signal. Okay, remember this point. No DC, over modulation, and that is possible with the synchronous detector. Over modulation means only synchronous detector. No DC means a modulated signal is nothing but message signal multiplied with carrier. That's it. Okay. So we'll see synchronous. Now this is the message signal, transmitter portion also. This is the message signal. I just take a product modulator, and this is the carrier signal. Okay. Now which is AC cos 2 pi FC. Now this is just message multiplied with carrier is nothing but, now this is nothing but AM signal. This is nothing but the AM signal, amplitude modulated signal. Okay. Now this is the transmitter side portion, right? But our synchronous detector is a demodulator, AM demodulator, means at the receiver side. So what is the input to the receiver? The input to the receiver is nothing but the modulated signal. Now this is the amplitude modulated signal is input to the demodulator. Now this is the product modulator or product multiplier. One input is an AM signal, and another input is a local oscillator. The local oscillator will be able to generate the same frequency and same phase of the carrier used at the transmitter side. See it? What is the frequency of the carrier at the transmitting side? FC. What is the frequency of the carrier at the receiver side generated by using local oscillator? FC. Now here the phase is, actually the phase is 0 degrees, but unfortunately my local oscillator at the receiver side is not able to generate the same phase. My local oscillator at the receiver side is not able to generate the same phase. Now will generate by a phase of some phi. Now this is AC cos 2 pi FCT plus phi. Now this is at the receiver side. Right? Now there is a phase difference of phi. So if the local oscillator is not able to generate the same phase, means some phase is mismatching. Okay. Now frequency is matching, but the local oscillator is not able to generate the same phase. So some phase is mismatching. What happened? We will see. Now, what is the output of the multiplier? Now this is the output of the multiplier at the receiver. Multiplier at the receiver is now AM signal. Now the amplitude modulated signal multiplied with local oscillator generated signal. The local oscillator generated signal, which is nothing but, what is the amplitude modulated signal? AC m of t into cos 2 pi fct multiplied with the local oscillator generated signal is AC into cos 2 pi fct plus phi. Okay. Now this is the output of the multiplier. Then if you simplify this, AC m of t, now cos 2 pi fct, now cos A cos B, cos A cos B, cos A cos B minus sin A sin B, minus sin A sin B. Now this is finally what happened. Now this is AC m of t cos phi, cos into cos, cos square. Cos square is nothing but 1 plus cos 2 theta by 2. AC cos phi by 2 m of t into cos 2 pi into 2 fc into t. Now minus AC into AC. Now this is also AC square, AC square. Now this is AC square m of t sin phi. Now this is cos theta sin theta. If you multiply it with 2, sin phi into m of t sin 2 theta. 2 sin theta cos theta sin 2 theta sin 2 phi into 2 fc into. This is the output of the multiplier at the receiver side, right? So, but what we are expected? We are expected the output of the demodulator is a message signal. Therefore, this is passing through a low pass filter. This is passing through a low pass filter. Now, this low pass filter gain versus frequency characteristics. This is the low pass filter whose gain versus frequency characteristics are like this. The gain versus frequency characteristics of a low pass filter is now from low frequencies to cutoff frequencies FM. This is gain 1. This is pass band. Now see here. Now this is 2FC plus FM. 2FC minus FM is not allowed by our low pass filter. 2FC plus or minus FM. Now this is 2FC plus or minus FM is also not allowed. So what is the output of the square law demodulator? The output of the square law demodulator is output of square law demodulator. The output of synchronous detector is the output of the synchronous detector is AC square by 2 m of t into there is a phase shift of phi. Now you see here, when phase shift phi, equal to 0, now this is 0 degrees. Here is also the phase shift is phi. Exactly, both phases are matching. So you understand what is the meaning of synchronization. Synchronization is nothing but synchronization between the carrier which is used at the transmitting side and a carrier generated at the receiver by using low class data. These two carriers should be perfectly synchronized. Okay. So when phase equal to 0 degrees, now see here, when phase equal to 0 degrees, the output of the demodulator is, the output of the detector is AC square by 2 m of t into cos 0. Cos 0 is nothing but 1, which is AC square by 2 into m of t. Then this is perfectly synchronized or not? Perfectly synchronized. This is perfectly synchronized. The carriers are perfectly synchronized. But the synchronization, which is not an easy task, which is very difficult task to synchronize the carrier at the transmitter side and carrier at the receiver side. But sometimes now the phase maybe changes, and maybe a phase may be 90 degrees. Means phase is mismatching of 90 degrees. Now if the phase is mismatching, then the output of the demodulator is, the output of the detector is AC square by 2 m of t cos 90, AC square by 2 m of t into cos 90 degrees, now which is nothing but 0. Output equals 0. Now nothing is coming, output is 0. Your cost, complexity, hardware and everything will be increases, and finally you can get output as 0 when phase is 90 degrees. This particular effect is called as quadrature null effect. Quadrature means 90 degrees. Now when phase is quadrature, output is null. Quadrature null effect. When a phase is 90 degrees, the phase difference is 90 degrees, then the output equals 0. This effect is called as quadrature null effect, which is a very dangerous effect because output is 0. Now your cost and complexity and everything is increasing, but our output equal to 0. Null is coming. So this is the disadvantage and dangerous effect in the case of synchronous detector. Then synchronization is very difficult task. You think that then the envelope detector is easy or synchronous detector is easy. Your cost is increasing, complexity is increases, and synchronization is very difficult task. Hardware implementation is also very difficult, and maintaining the synchronization by using low class data at the receiver is also very difficult. Such a difficult task you want to go through, you want to pass through, and finally sometimes the output may be 0. Then that is nothing but a quadrature null effect. Now that is the reason why then this synchronous detector is not at all a preferable method. Now where there is an AM modulation technique is involved, now definitely at the receiver the demodulation is successfully done by envelope detector itself. So we already fixed in our mind that practically the demodulation of AM is done by envelope detector. If your demodulation technique of AM is only by using envelope detector, such that you can get n number of advantages, to gain those advantages at the transmitting side, now you add a suitable DC component such that the demodulation is always possible by using envelope detector, because always the modulation index should be less than or equal to 1. Okay, so that is the reason why this synchronous detector is not preferred practically. Therefore the synchronous detector, first we'll write here, cost increases, cost is increased, complexity is increases, cost increases, complexity increases, synchronization is very difficult. Synchronization is very difficult task and dangerous effects will come. Quadrature null effect. Now, such a disadvantage which we are facing, disadvantages of synchronous detector. Based on these disadvantages, synchronous detector is not at all preferable. Synchronous detector is not at all preferable. Understand? This is the major disadvantage of the synchronous detector. So who will face all these disadvantage? There is a very simple, just 5 rupees cost is less than the 5 rupees cost just by spending a diode, capacitor and resistor, and you can get a number of advantages. Why you lose that advantage? Only the thing is just add a suitable DC component. Make always the DC addition message signal is completely positive. Mu is less than or equal to 1. No over modulation. Allowatory is successfully working. Okay. In order to increase this cost and complexity, then see how the difficulty what we are facing here. Okay. Now, not only this is the only one side of this coin which we are covered. Now, when phase is matching, okay, good. But when phase is mismatching, this is the quadrature null effect. And sometimes there may be frequency mismatching also. If there is a frequency mismatch, then there is some other effect. Okay. So why we want to face those difficult tasks and we forcefully? Then there is a easy method which is already available. So you go for that one. Okay. Now, even if you want, no, sir, I want to demodulate the over-modulated signal. I am not interested on the analog detector. Then this is the synchronous detector technique which is available, but nobody will prefer this type of technique. Okay, or not? When phase equal to 0 degrees, perfectly synchronized, no problem. When phase is 90 degrees, quadrature null effect. But when phase is in between 0 degrees and 90 degrees, what happened now? When phase is in between 0 degrees and 90 degrees, the output signal is multiplied. This is cos phi, no? Now cos 0 is 1, cos 90 is 0, but this is in between, less than. So output signal is multiplied by a factor of less than 1, such that what happened? The signal strength is decreases and signal to noise ratio is decreases. When the signal to noise ratio is very less, when the signal to noise ratio is very less at the receiver side, then the demodulation is not possible. If the signal to noise ratio is decreases, if signal to noise ratio is very less, demodulation process is not possible. Demodulation is not possible. First of all, the demodulation by using any method is a secondary. Demodulation itself is not possible if the signal strength is very, very less and noise is dominating. Clear or not? So the demodulation process are not at all possible, not by using synchronous, not by using any other detector, okay? Because the synchronous detector or any other detector is not able to get back the signal because the noise is very, very high. The noise domination is more. A signal strength is very less. How I can get in that particular signal as a message signal, okay? Already the noise is dominating here. I cannot get back the original message signal from that noisy modulated signal, okay? If this is good, then we are doing any other kind of demodulation technique in order to get back the original message signal from the modulated signal. Okay, so this is the problems what we are facing in the case of synchronous detector. Now, by keeping all these particular points in our mind, we never prefer synchronous detector practically. The practically preferable method for demodulators of AM is only the best one is envelope detector. Okay, no doubt.